how can you navigate the world of agents? You hear a lot of terms like single agent, multi-agent, tools, models, etc. So today in this workshop, what we want to do is break down a lot of the nuances around this. We want to go over the anatomy of an agent, different agentic structures, and then go over the pros and cons for each one so you know exactly what to use for each use case. Today I'm with Caleb, and let's start with the anatomy of an agent. So I think a really interesting thing to start with is how do we define an agent? I think the easiest definition that I've seen is adding agency to software. How would you define it?
Yeah, I mean, I guess it needs to be agentic, right? So personally, I like to define them as something that is capable of making decisions in an action space.
What would you say the biggest difference between something that's an agent and something that's an LLM-based agent? You know, because I think a lot of the times those things get confused.
Yeah, so there's a whole literature of research done around agents before large language models were even things. And there's a lot of formalism around those definitions. And they do share some elements, particularly around like these ideas of action spaces and responding to events, but they're mostly hard reasoning agents before large language models. I think for this video it makes more sense to talk about the large language model based agents and fuzzy reasoning systems.
Definitely, because I think when most people refer to an agent, that's what they're talking about, at least in recent times.
Yeah.
So the sort of basic structure that I think most people tend to have is they'll have a LLM. So this might be, usually it's like something to do with OpenAI. And then within that, they'll probably have some tools. This probably could be built together with some kind of framework, might be Camel, LangChain, Crow AI, whatever. But the core principle really is framework, model, tools. Yeah, if you want to go a little bit more advanced, there might be things like loaders, memory. You know, there are some things you can build on, but I think let's keep it simple.
Yeah.
I think sort of going from the anatomy, let's talk about a few structures. So this right here, this is just a single agent. So it's just, okay, there's one input, there's one output. You can put things in, do it. Kind of moving away from this, another one I want to talk about is a sort of more of a router agentic design. So you could have this input here from the user, goes in, this is single agent output, but if you want to do something like a router, this is where it could send it off to other agents dependent on the task. So this is one agentic design. It's kind of single agent based. To make it more multi-agent, which it is multi-agent now, there's another
commonly people would just add tools which represent these agents, and then they get called like their tools. Sorry, go on, yeah.
Yeah. No, definitely. And I think a more famous example of this router system on a bit of a high level is something like Workforce, if you're familiar from Camel. So there's usually one coordinator agent, and then there's sort of many different worker agents where depending on the task, it can speak to different agents, right? And I think an even more complex implementation of this would probably be OWL. Would you say it works the same way? Does it have the worker agent structure with all the other agents, or?
Yes. Yeah.
Nice. Yeah. So then going off that, the next agentic structure I want to talk about is role playing. So this is something again from Camel AI. It's kind of a similar thing where you have one agent. This sort of plans things, but then instead of distributing it to just one other agent to complete the task, it's going to be distributed to two different agents, which then talk to each other. So they're going to role play a certain subject. So an example they have is to build a game. So the user asks, okay, how can you build a game? The planning agent would define some sort of inception prompt. This would go to the role playing. One would act as a user, one would act as a assistant, and they'll go back and forth until they actually complete the task. Kind of going away from these single agent kind of designs, there's one I want to talk about, which I think is probably the most common one that's used, and this is a workflow structure. So this is kind of the same as the single agent, but instead of just being one agent, one output, it's usually you have different agents doing different tasks that sort of go in like a flow. So like an example that I've used for this is web scraping. So when I built a web scraper on NA8 kind of thing, where you have one agent that does one thing, one agent that does another thing, one agent that does another thing, But from what Caleb's saying as well, this might not be the best way to do web scraping. So maybe you could talk about some examples where workflows are quite limiting.
Yeah, so I mean, this is very natural, I think, for software developers, because we're used to building things in stages and functions, and maybe you have some logic, some code logic between them to help decide what comes next. The problem is, though, is that the nature of the work that large language models tend to be employed for is the kind of work that you can't exactly write an algorithm for. So with the example for web scraping, you might be familiar with times where you went to a web page and you get like a 500 internal server error, and then you refresh and instantly it's back, right? Or maybe you get a captcha that needs to be solved. In these sorts of kind of flow-breaking events, the whole flow can be not very adaptive to overcoming them. So maybe, for example, your scraping system needs to first have one agent on the page and find all the links and then give them out to other agents to be parallelized. If it first gets a 500 error, then the other agents are not going to have anything, right? Or maybe down the line, one of them runs into a captcha, and then the agents that one's meant to send links to are in the dark as well. So it's these sort of flow-breaking events where you might want something that's more adaptive.
Definitely. And just to give you a quick visualization, so I think now we're kind of moving away. How do you define these models? Because I think there's like a class of multi-agent systems where it's usually there's a one-agent blocker. Like, do you have any name for this, or
one-agent blocker?
So you need like workforce, like workflows. Like there's usually like a thin line of.
Yeah, I mean like pipeline or workflow. I mean these things are necessarily ordered, right?
Yeah.
You could say ordered.
We'll say ordered. So we have these kind of ordered multi-agent systems.
Yeah, or maybe pipeline makes sense as well, because while they are ordered, you might have branches still.
I'll use the workforce example because I think that's probably the one I'm most familiar with. And then the kind of multi-agent system, just for more context to visualize it, that we're talking about, it's more like a graph. So maybe you could explain that sort of structure a little bit more.
A graph structure?
Yeah. Like I guess the one we're most familiar with is the thread style Slack structure.
Oh yeah. For a more adaptive approach, you can instead have the agents running asynchronously. So each of these has their own loop, right? So in the previous one we were looking at, the program flowed once through. But in this approach, each of these agents is in their own loop, which is flowing through repeatedly. And as they're iterating, as they're going through this loop, they have, as part of their action space, they have the choice to interact with other agents. And this can be through discovering them. So in core, we have a list agents function, which describes the agents that are nearby and what they're capable of. And it could be sending a message to them or creating a thread with several of these agents to collaborate on something. So in this case, when you encounter these flow-breaking events, the large language models can use their intelligence to overcome them. So for example, when we encounter a 500 error on a page, the agents can reason that they can try again. You might add something to your prompt to make it more robust, and but yeah, they're able to work around things. So you might have one encounter a captcha. It might then send a message to a human asking for help to do the captcha. So these sorts of systems are a lot more adaptable.
Nice. And so I guess these are more like communication structures. So I guess you've got the kind of comparisons in this we're talking about. But I think there's another comparison in the structure. I'm not sure if there's like a word for it, but it's about more of the Internet of Agents approach, where instead of you having all these agents in one system and one framework on like a local thing, instead you can have each of the agents ran by different vendors and developers. Maybe you could speak to the benefits of that.
Yeah. So it's kind of similar to what you already have with the micro service architecture in software, where because there's this common code interface between these agents, what that means is that it's a lot simpler for less connected people to actually work on the same system. So for example, with microservices, what's nice is that you, in a big company, you might have one team per microservice. And we can actually go even further than that. If it's well defined enough, like with the HTTP API, then you have this ability to have completely different companies working on agents and then sharing their capabilities. the benefits of that, I think, are kind of obvious. But when you combine it with open source, you also end up with very robust agents and well-tested agents that people get to use, and highly specialized ones as well.
Nice. I guess to kind of summarize all these pros, because I think as well. So just for a little bit more of context, we're working on this kind of structure, but I don't think it's the best thing for like every single use case. I think each kind of structure has
these flows have their use cases as well.
Yeah.
I mean, for Coral, actually in the future we're going to try and work on a hybrid approach, but that's still in planning. But the idea will be that you're able to prescribe and enforce certain interactions. I think one really nice way to do it could be that you actually have kind of contracts between these agents about specific shapes of data that needs to be exchanged, and that way you kind of get to force a certain flow while still allowing them to recover from flow breaking events. But yeah, it's still a work in progress.
Nice. Yeah, no, definitely. So I guess as a quick summary, if you're developing a use case, when do you think you should use a single agent? I guess it's just like anything simple that you could include all the context in one prompt.
I mean, there are cases where a single agent like works really well for it, and it doesn't encounter things that it can't recover from. For example, a chatbot that's just meant to be entertaining.
Sure.
You probably won't be that much more entertained. Oh, I mean, it could be fun to talk to like a whole server of chatbots, but yeah, like if it's doing its job well, then obviously you don't. If it's not broken, don't fix it, right? And there are cases of single agents that are not broken.
Yeah, I guess because I think a lot of times I see people build multi-agents which probably don't have that much difference to single agents. Like I saw an example yesterday where it was like a sales pitch advisor, and it was just like the agents were broken down into 4 different things, which I think, okay, that could just be one prompt. So would you say it's really about context management and like tools? And
it's kind of, you could say that like having more agents is one approach to context management. A better way of thinking about it though is in terms of responsibility. So if all of the agents in your multi-agent system have exactly the same responsibility, then you don't really benefit much. So what you need to do is you need to make sure that they have separate responsibilities that are small enough for them to handle. If they're too big, you break them down into more agents. And those responsibilities can include just a separate part of the task or a separate nature of work that they need to do.
Yeah, so I think just as the last thing we go, so like what do you think when do you think you should use these like linear workflow stuff versus this graph approach?
If you know that there are not going to be flow-breaking events. I mean, earlier you were trying to come up with an example of a case where there wouldn't be flow-breaking events, and you came up with web scraping.
Yeah.
And then I named some examples. So it's actually quite hard to know in advance whether there will be, but sometimes there's not. But the nature of these systems, it does tend to be that the unexpected flow-breaking events, but conceivably there are sometimes not as well, and then this can be quite appropriate for that.
I guess the sort of famous example we say is like these systems can only scale to as much as this one agent can handle responsibility-wise. But if you have it as a graph and all the responsibilities are split pretty well, in theory you can scale it out.
So that's another weakness of this approach, really. But yeah.
Yeah, but I think that was a quick overview. I think I just want to end it on a bit of a talk about Coral and like how you can build on it. So the basic idea is you can take any agent from any framework, language, or vendor, and you can put them in this sort of graph-like approach where you can have them collaborate to be put in software. Kelim, is there anything else what you want to add, like how to get started and where's the best ways to look at it?
Yeah, so I think the best way to get started is probably just to go look at our guidelines and find an example you think is most interesting, get it running locally, and then probably just to go and play with it. Like you can edit the agents. In our examples, we show how to run them from source code. In a production setup, obviously things don't tend to run from source code directly. You might have Docker images, and we make it very easy for that and as well in the future if you want to make it a production system. But for getting started, get it running locally, play with the agents, and maybe you'll get some ideas. Yeah,
definitely. Below this, we have a guide, just like step-by-step of like how to do it. You can use Coral Studio to monitor all your agents and see it happens. And then for the hackathon, we've actually included example use cases with Coral for every single track. So you'll be like, okay, this is Coral with Vultr, this is Coral with Qualcomm, we've done all of them. So feel free to check them out. We look forward to see what you build at the hackathon. Be to you soon.
Thanks.